Science, Grade 10, Quantification of Elements and Compounds, Unit 7. In this unit, we are going to discuss about the relative atomic mass AR, relative molecular mass MR, and Avogadro constant and mole. Avogadro, Amedeo Avogadro, born in August 9th in 1776 in Turin in Italy and died July 9th in 1856. He was an Italian mathematical physicist. I have shown a picture of the Avogadro here. Now we are going to measure the mass of some things here. Relative atomic mass. This is our topic. The mass of a cement bag, as you all know, it is 50 kilogram. Here we use the unit kilogram. How do you calculate the mass of a medicine tablet? How much is it? It's nearly 100 milligram. The mass of a motor car is 1200 kilogram. The mass of a loaf of bread is 500 gram. The mass of a brick is nearly 1 kilogram. Here we have used kilograms and milligrams to measure mass of some substances. Grams, kilograms and milligrams. How do you measure the mass of an ink dot like this? Put at the end of a sentence, it is about 100 microgram. There are more subunits to measure the mass. What are they? Now these are for your memory file. 1000 grams equals 1 kilogram. 1000 milligrams equals 1 gram. 1000 micrograms equals 1 milligram. 1000 nanograms equals 1 microgram. 1000 picograms equals 1 nanogram. 1000 femtograms equals 1 picogram. 1000 attograms equals 1 femtogram. How do we measure the mass of atoms, molecules, protons, such minute things? What is the weight we use to measure those? The smallest subunit of the gram scale is also too much to measure the mass of atoms, molecules, protons, electrons and neutrons. Atomic mass of hydrogen is 1.67 into 10 to the power minus 24 gram. It is represented like this. So, therefore the atomic mass unit mu is adapted as an alternative unit to measure the atomic mass. In the past, the mass of hydrogen atom was selected as the unit, but due to some reasons, oxygen atom was selected. 1/6 of mass of oxygen atom was used as the unit. Later, 1/12 of the mass of carbon atom was selected. The International Commission of Atomic Weights in 1962 selected 1/12 of the isotope carbon 12 as the standard unit. You know this is the mass number carbon 12, this is the atomic number 6 atomic number and mass number. So 1 AMU equals 1/12 mass of carbon 612 isotope atom. This is the unit we use to measure the mass of atoms, molecules, electrons, protons. Atomic mass unit. Atomic mass unit equals mass of the carbon 612 isotope divided by 12. So the mass of the carbon isotope is 1.99 10 to the power minus 23 grams. You have to divide by 12, then you get 1.66 10 to the power minus 24 grams. Relative atomic mass. The relative atomic mass of an element is the mass of an atom of that element relative to 1/12 the mass of carbon 12 isotope. Here I have given you an example. Mass of a carbon atom is 1.99 10 to the power minus 23 gram, and the mass of a magnesium atom is 4.03 10 to the power minus 23 gram. Now we are going to find the relative atomic mass of magnesium. How do we find relative atomic mass of magnesium? Mass of magnesium atom divided by mass of carbon 612 isotope atom and multiplied by 12. 4.03 10 to the power minus 23, you have to divide by 1.99 10 to the power minus 23 into 12. So you can simplify these two and you can divide these two and multiply by 12. So the answer is 12. I think you all know how to divide decimal numbers. There is no unit as it is a relative value. No unit for this relative atomic mass. Another example, the true mass of an oxygen atom is 2.66 10 to the power minus 23 gram. True mass of carbon atom 1.99 10 to the power minus 23 gram. You have to find the relative atomic mass of oxygen. Relative atomic mass equals mass of an oxygen atom and divide by mass of a carbon 612 isotope atom and multiply by 12. What is the mass of an oxygen atom? It is 2.66 10 to the power minus 23 given in the question. Mass of a carbon atom is 1.99 10 to the power minus 23. You can simplify these two. There are two decimal numbers here. Then you can convert this to 199. Here 266. You have to divide 266 by 199 like this. The answer is 1.33 and multiply by 12. The answer is 16.04. So we can take it as 16. The relative atomic mass of oxygen is 16. Another example, the mass of a potassium atom is given as 6.476 10 to the power minus 23 gram. The mass of carbon atom is 1.99 10 to the power minus 23. So you have to find the relative atomic mass of potassium. Relative atomic mass of potassium equals mass of potassium atom divided by mass of carbon atom into 12. So what is the mass of potassium atom given in the question? 6.476 10 to the power minus 23. We have to divide by mass of carbon atom 1.99 10 to the power minus 23. You can simplify minus 20 10 to the power minus 23. And the answer, there are two decimal numbers here. Then it becomes 199. Here you can move two decimal numbers here. 647.6. Then you have to multiply by 12. So the answer is, when you divide 647.6 by 199, the answer is 3.2. Multiplied by 12, you get the answer 39. Same can be done like this. The previous examples to find the relative atomic mass of the oxygen atom, you have to divide by mass of carbon atom. It's easy, I think. Mass of oxygen atom is 2.66 10 to the power minus 23. The mass of a carbon atom is 1.66 10 to the power minus 24 here. Keep this in mind. If you simplify, this number becomes 166. 110 goes up. So 2660. You have to divide by 166. Then you will get 16.02. The second example, mass of a potassium atom 6.476 10 to the power minus 23. Mass of a carbon atom is 1.66 10 to the power minus 24. atomic mass unit. So the answer here, there are two decimal numbers, so it becomes 100 and 166. When it moves here, two decimal numbers, then 647.6, and 110 comes here, so then you can add 10 here. Then you have to divide it and get the answer 329.01. That is the relative atomic mass of potassium atom. Mass of a sodium atom is given as 3.819 10 to the power minus 23 gram. The value of atomic mass unit 1.66 10 to the power minus 24 gram. You have to find the relative atomic mass of sodium. How do we calculate? What comes here? 3.819, that is the mass of sodium atom. And here mass of carbon atom, or value of atomic mass unit. What is the mass of sodium atom given in the question? 3.819 10 to the power minus 23. The atomic mass unit is 1.66 10 to the power 24 grams. So if you simplify this one, you get the answer 23. Another example, the mass of an atom of element A, this is in your textbook. A is 8 times the mass of carbon isotope. Find the relative atomic mass of A. Relative atomic mass of atom A, you have to divide by the value of atomic mass unit. This is the first method to calculate it. The mass of atom A is 8 times of the carbon isotope. 8 times mass of carbon atom and the value of atomic mass unit. The mass of a carbon atom is, as you all know, 1.699 10 to the power minus 3 times 8 and divide by 1.66 10 to the power minus 24. So if you simplify this one, you get the answer 96. Second method to find the same answer for the same question, relative atomic mass of an atom of A divided by mass of a carbon atom into 12. So the mass of a carbon atom is 8 times 8 into mass of a carbon atom, and mass of a carbon atom, you can simplify these two, and 12 times 8 is 96. The answer is 96. Then we are going to discuss about the relative molecular mass. We discussed about the relative atomic mass. Now we are going to discuss about the relative molecular mass. What are molecules? You know, if you take water, the formula is H2O. It's a molecule. If you take carbon dioxide, CO2, it's a molecule. If you take calcium carbonate, CaCO3, they are molecules. So how do we find the molecular mass of those molecules? Relative molecular mass. So this is the equation. Mass of a molecule of an element or compound, we have to divide by mass of a carbon atom into 12. The true mass of a carbon dioxide molecule is given 7.31 10 to the power minus 23 gram. Mass of a carbon atom is 1.99 10 to the power minus 23. I think you are familiar with this number now. Keep this in mind. Find the relative molecular mass of carbon dioxide. Relative molecular mass of carbon dioxide. Mass of a molecule of carbon dioxide, 7.31 into 10 to the power minus 23. Carbon atom, 1.99 10 to the power minus 23. You can simplify these two and divide these two numbers, then you get the answer 44. The mass of a water molecule H2O is 2.99 10 to the power minus 23 gram. Atomic mass unit. You can use the atomic mass unit without multiplying by 12 to find the relative molecular mass. How do you find relative molecular mass? Mass of a water molecule divided by atomic mass unit. Mass of a water molecule is 2.99 10 to the power minus 3. minus 23, and we have to divide it by atomic mass unit, 1.66 10 to the power minus 24. Then we will get the answer 18. If the molecular formula of an element or a compound is known, its relative molecular mass can be calculated. How do we calculate? If we know the atomic mass, we can calculate the relative molecular mass of the molecules. Now first we will take the hydrogen molecule, H2. Mass number is 1. There are 2 hydrogen atoms here. 2 times 1, 2. Nitrogen, atomic mass is 14. Mass number is 14. 2 times 14, 28. What is the mass number of oxygen? It's 16. So 16 times 2, 32. What is the molecular mass of carbon dioxide? Carbon is 12, oxygen 16 times 2. How do you calculate? Carbon 12, there are 2 oxygen atoms here. 2 times 16, 32. 32 plus 12, 44. Glucose, C6H12O6. There are 6 carbon atoms. So 6 times 12. Hydrogen 1, 12 times 1. Oxygen 16 times 6. If you add these three, the answer is 180. Ammonia, NH3, nitrogen 1 atom, hydrogen 3 atoms. So how do you calculate nitrogen? 14, 3 times 1, 3. 14 plus 3, 17. Sulfuric acid or battery acid, H2SO4. Hydrogen 2, sulfur 1 atom, oxygen 4 atoms. 2 times 1, sulfur mass number is 32, oxygen 16 mass number, there are 4 oxygen atoms. So the answer is 98. 2 times 1 plus 32 plus 16 times 4, 64. We have to add all, then you get the answer 98. Now we are going to discuss about Avogadro constant and mole. Avogadro number is defined as the number of atoms in exactly 12 grams of carbon 612 isotope. You know, this is the atomic number, this is the mass number. Avogadro number is defined as the number of atoms in exactly 12 grams of carbon 612 isotope. Mole is the amount of substance in an Avogadro number of particles. So what is the quantitative value of Avogadro number? It's 6.022 10 to the power minus 23. The amount of substance in Avogadro number. This is called the mole. Molar mass is described as the mass of atomic mole of an element or compound. Now we are going to discuss more about this. Calculating number of moles and Avogadro number. I have taken both together here, then it's easy for you to understand. Now if we take hydrogen 1 gram, if you take hydrogen 1 gram, carbon 12 grams, nitrogen 14 grams, oxygen 16 grams, sodium 23 grams, or magnesium 24, calcium 40 grams. Mass number in grams. So they are having the same number of, equal number of moles. If we take hydrogen 1 gram, 1 mole, carbon 12 grams, 1 mole, 14 grams 1, 16 grams 1, 23 grams 1, and 24 grams also 1, and calcium also 40 grams 1. Now we will take the number of atoms. If we take hydrogen 1 gram 1 mole, same number of atoms, 6.022 10 to the power 23 Avogadro constant. Carbon 12 grams also Avogadro constant. Nitrogen 14 grams of the same number of atoms. Oxygen 16 grams, 1 mole, same number of atoms. Sodium 23 grams, number of moles 1, and number of atoms, can you guess? The same number. Magnesium 24 grams, how many moles? 1 mole. And the atoms also Avogadro constant number 6.022 10 to the power 23. If we take calcium 40 grams 1 mole 6.022 10 to the power 23. Now if we take hydrogen 2 grams, the number of moles 2. The number of atoms 6.022 10 to the power 23 times 2. Carbon mass number is 12. Here I have taken 24. So the number of moles is 12. So the number of atoms, how do you calculate the number of atoms? Now look at this. 6.022 10 to the power 23 times 2. Then carbon, if we take carbon 6 grams, the mass number of carbon is 12. This is half. So what is the number of moles here? 0.5. What is the number here? 6.022 10 to the power 23 multiplied by 0.5. If we take carbon 3 grams, what could be the answer here? Can you guess? 0.25. The answer 6.022 10 to the power 23 multiplied by 0.25. Then if we take carbon 48 grams, carbon, the mass number is 12. So the answer is 12 times 4, 48. What is the answer here? 6.022 10 to the power 23, you have to multiply by 4. Mass number of oxygen is 16. If we take oxygen 8 grams, what is the number of moles? Can you guess? 0.5. So the number of atoms like this, you can calculate it like this. Oxygen, if we take 4 grams, half of this, 0.25. The number of atoms, you can calculate it like this. If we take nitrogen 7 grams, the mass number of nitrogen is 14. So, can you guess the answer here? Think. 0.5. What is the answer here? Right. These are the answers. You should calculate like this. Now, if we take hydrogen 2 grams, as we explained earlier, number of moles 1, number of molecules 6.022 10 to the power 23. Now here I have taken the molecules, number of molecules, the same number of molecules in hydrogen 2 grams. Number of moles 1. If we take carbon dioxide, you know how to calculate this number, relative mass number, carbon 12, oxygen 16 times 2, 44, 32 plus 12, 44 grams. 1 mole, the number of molecules also 6.022 10 to the power 28. This is the Avogadro constant. If we take ammonia 17 grams also, the same number of moles. 1. Number of molecules 6.022 10 to the power 23. If we take sodium hydroxide 40 grams, sodium 23, oxygen 16, hydrogen 1. So the answer is, can you guess the answer? 1. What is the answer here? same number. Glucose. Now what is the mass number of glucose? We have already calculated. The answer is 160. If you take 160 grams, the number of moles 1, same number of molecules. Sulfuric, you can calculate hydrogen 2, sulfur 32, oxygen 16 times 4, 64 all together. What is the answer? If you add 98 grams, number of moles 1, number of molecules the same number. Then CH3OH, 32 grams, 1 mole, the same number of molecules. Calcium carbonate, CaCO3, 100 grams, calcium 40, carbon 12, oxygen 16 times 3. If you add this, you get 100 grams and 1 mole, and the number of molecules, same number, Avogadro number. Nitric acid, HNO3, 63, hydrogen 1, nitrogen 14, 16 times 3. So the answer is 63 means number of moles 1, number of molecules, what is it? Same number. If we take hydrogen 4 grams, number of moles 2, molecules 6.022 10 to the power 23 times 2. Carbon dioxide, 44 grams is 1 mole. I have taken 82 grams, so the number of moles 2, number of molecules, can you guess? What is the answer? 6.022 10 to the power 23 times 2 because there are 2 moles. Then carbon dioxide 22 grams. What is the answer here? Can you guess? 0.5. What is the answer here? 6.022 10 to the power 23. You have to multiply by 0.5. Then carbon dioxide 11 grams. What is the answer? 0.25. What is the answer here? You have to multiply by 0.25. Ammonia 28 grams, 2 moles, 17 times 2. What is the answer here? 6.022 10 to the power 23 times 2. Ammonia 7 grams. What is the answer? 0.25 here. 6.022 10 to the power 23 times 0.25. Sodium hydroxide 10 grams. Can you guess the answer here? 0.25, and here you have to multiply by 0.25 the Avogadro number. If you take sodium hydroxide 5 grams, answer is 0.125. Here the answer is 6.022 10 to the power 23 times 0.125. That is the end of this unit. If you want to see more videos, please do subscribe to my channel. Thank you.